Hello, in this video we'll be talking about matrices. In R, a matrix is a two-dimensional array of elements of the same data type organized into rows and columns. Matrices can be created using the matrix function, which takes in a vector of elements and the number of rows and columns to arrange them in. Let's create a matrix A. We use the matrix command, and we pass into it some data, a vector in fact. You'll recall that the C command will give us a vector. You can see as well in the yellow area, R wants us to give it a number of rows, number of columns, and by row and dimension names. All we need to really do is give it the number of rows. Once it has the number of rows, it can figure out the number of columns. So you can see in our environment pane, we've got A is a numeric matrix, and it's got the numbers 1, 2, 3, 4, 5, 6. If we go back to the console and we type in A, we can actually see our matrix. Now you can see that we've assigned these values column-wise. So 1 and 2 were the first two values in our array. So those become column 1. 3 and 4 were the next two values. Those become column 2. 5 and 6 were the last two values. Those become column 3. If we want to create another matrix that ordered our data by row rather than by column, we can do that as well. Let's call that matrix B. So we'll give it the same vector. We'll still tell it that the number of rows is 2. But here we'll add in by row equals true, because we want to order the data by rows rather than by columns. You can see in our environment tab, we've got our value B. And back in our console, if we type in B and hit enter, we get that same data, 1, 2, 3, 4, 5, 6, this time ordered by rows. If we want to reference particular elements in a matrix, we do it in a similar way to how we referenced elements in a vector. So for example, if we say A square bracket 1 comma 2 and hit enter, that'll give us a 3. A12 references our A matrix, and it looks for the entry in row 1, column 2. And we can see that that's a 3. If we say referenced A21, looking back at our A matrix, that'll be the element in row 2, column 1, so that should be a 2. And it is. If we want to reference entire row or column, we can do that as well. So let's look at B 1 comma nothing. That gives us all of row 1 with every column. We could also reference just a column by going B comma, let's take the third column. So it's every row, column 3 of our matrix B. You'll notice there for B square bracket nothing comma 3, we get a column, the third column, but it's horizontal. We can change that to be a vertical column by simply adding in drop equals false. So B square bracket nothing comma 3 comma drop equals false. And there we get our column and it looks like a column. If we want multiple parts of our matrix, let's say we wanted the first two columns of matrix A. We type in A, square brackets to reference rows and columns. If we want the first two columns, we're also going to want all of the rows. So all of the rows means we leave the row part blank, comma, first two columns, give it a vector that references the first two columns. And there we go. We've got a matrix that has every row and only the first two columns. Let's take a look at matrix A again. If we want to find the transpose of matrix A, we can use the T function. And of course, the transpose function turns the rows into columns and the columns into rows. If we want to put two matrices together, creating a new matrix that's essentially one matrix combined with the next matrix, we can use the cbind command. So let's bind together matrix A and matrix B. So this is probably exactly what you expected. We have the first three columns are matrix A, and the next three columns are matrix B. And they've been combined into a new matrix that's 6 columns and 2 rows. If we want to bind something vertically, we can use rbind. So let's bind matrix A and B, but we'll put matrix B below matrix A. And here we go, we have matrix A on top of matrix B. We can also do basic arithmetic operations with these matrices. For example, we can add two matrices. If we wanted to add matrix A to matrix B, we can do that. And it's done in the way that we normally think of matrix addition, component-wise. We can subtract A minus B. And we can do normal matrix multiplication. Now remember, matrix multiplication isn't done component-wise. So you have to have the columns of the first matrix be equal to the rows of the second matrix. In our examples A and B, that's not the case. So, well, it's easy to add and subtract A and B because they're the same dimensions. Because they're not square matrices, it's a little harder to multiply them. Let's create two new matrices. We'll create matrix C. It'll be a 2 by 2 matrix. So there's matrix C, 1, 2, 3, 4. Matrix D. Make it the numbers 1, 3, 5, and 7. Again, a 2 by 2 matrix. Okay, so there we've got our two new matrices. Because they're square with equal dimensions, we can multiply them together. And to do that, we take C and we go %* D. And there we go. We've got our new C times D matrix. So matrix multiplication works exactly how matrix multiplication works in your linear algebra class. If we wanted to multiply A times the transpose of B, so A is 2 rows, 3 columns, and the transpose of B would be 3 rows and 2 columns. We could do that. We go A times transpose of B using the T command. And again, we can get a solution there. Take a few minutes and play around with the different functions that you can apply to matrices.